Chapter 10 is all about geometry. This first section, section 10.1, is on points, lines, planes, and angles. So there's a lot of vocabulary in this first section. Now I apologize, I know this slide is very wordy, so I'm just going to summarize it. I'm going to go to the examples right below that wordy box there. And if I look at some of the pictures, the first picture I'm circling is an example of a point. So that's point A. But the idea here is that a point throughout this chapter is going to be represented the same way as it was in your algebra course. So whenever you see a solid dot, closed dot, that's going to represent a point. And a point has no length, no width, and no thickness to it whatsoever. If I hop down a couple spots below that example of a point, we see a drawing of a plane. So all of our shapes in this chapter are technically being drawn in planes. And a plane, the best way to think of it is picture a piece of paper, but pretend that that piece of paper is completely flat. It has no thickness to it whatsoever. And let's also pretend that that piece of paper goes on forever in all four directions. And that is a plane. So a plane is a flat surface with no thickness and no boundaries. We also want to make sure that we are familiar with the difference of a line versus a half line versus a ray versus a line segment, because we're going to see that language used in a lot of the directions in the MyMathLab assignments. So if I look at the bottom of the slide, we see that a line does connect any 2 points, but what makes it a line is you're going to see arrowheads on both sides, meaning it goes on forever in both directions, just like when you were graphing lines in your last algebra course. If you look below the example of that line there, it shows you the notation that you can use. So we could call this line AB, or we could say line BA. The order for a line doesn't matter, so AB, BA, it's still referring to the same line, and you would just literally draw a picture of a line right above the letters. If I go right beside it, I can see the difference between a line versus a half line. So a half line, I'm going to erase a little bit here, but a half line does have an arrowhead on one side, so it goes on forever in one direction. However, what makes it different than a normal line is that the other side does not have an arrowhead, but instead it has a hole, an open O. So technically you would not include that point on your half line. So this would be read out loud as half line AB, but technically the half line begins after point A. Point A itself is not included on that half line because there's an open O, a hole there. And the notation for that is you would list where the hole is first, and you would draw the hole above it. So you can see I've circled the notation for half line AB right below the example of it. And if I go right beside that, a ray also has an arrowhead on just one side of it, so it goes on forever for one side. The other side does not have a hole. It's a normal solid closed point, so it has an endpoint on the other side. And we're going to see in a minute that when you put two rays together and they have a point in common, that endpoint in common, it forms an angle. But a ray, again, has an arrowhead on one side, so it goes on forever on one side, and the other side is a closed dot, an endpoint. And then finally, in the very end here, a line segment has no arrowheads. It does not go on forever with either side, and it has closed dots for both endpoints. So it has two endpoints on either side of it. And for examples of how you would read it out loud or what the notation would look like, please look below each of these examples for the notation. So as I briefly mentioned on the last slide, an angle is formed when you put two rays together, and those two rays have an endpoint in common. So I know I'm horrible at drawing, so please forgive me here. But remember, a ray has an endpoint on one side of it and an arrowhead on the other side. So if their endpoint, they share that endpoint in common, and we merge two rays together, voila, we have an angle. And then one ray is going to be called the initial side, and then the other ray will be called the terminal side. The endpoint that the rays have in common, that's the middle point of an angle, is called the vertex. So if I look around the middle of this slide, we see an example of an angle. And unfortunately, there are so many different ways they can label an angle notation-wise in the MyMathLab homework. So you got to be really careful here. So you can see the vertex is point B, that's the point in the middle. That's that endpoint that the two rays have in common. If you look closely at the example I've circled in blue, we can use letters to label angles. We can also just simply use numbers. Got to be really careful when they use numbers though. As long as there's no degree symbol above the number, we know that number is a label and not an angle measurement. And I'll talk more about that later in this video. But for now, just be aware we can use letters or we can use numbers when we're referring to certain angles in our picture. So this example I've just circled, we could call it angle 1. And notice the symbol for angle, it's an angle with like a little arc drawn through it. But we could call this angle 1. We could just use the letter that's on the vertex alone. So I could say this is angle B. Remember, point B was the vertex. Or I could say this is angle ABC. So if I choose to use 3 letters, I would follow the rays in the order that I read the letters. So I just circled ABC. So if I go A to B to C, if I highlight that in red, I can see which angle they're referring to. Or you could even call it CBA, angle CBA. As long as that vertex letter's in the middle, if I follow C to B to A, you see that we're referring to the same exact angle. So there are 4 different ways that they can name this angle. What's very important vocabulary-wise is if I look at the vocab near the bottom of this slide with all the clock pictures. So we can classify angles as acute, right angles, obtuse angles, or straight angles. Let's start with actually the 90-degree angle. So a 90-degree angle, which is part B, the clock labeled B, I'm circling it in green right here. A 90-degree angle is a right angle. And sometimes they'll tell you if there's a right angle by using a little box or a square shape, but they don't always tell you it's a right angle. But if you do see that box from here on out, you want to immediately think, okay, that's a 90-degree angle, a right angle. So anytime you have an angle that's like the corner of a piece of paper, that's a 90-degree angle. Depending on how you turn it, it could look like a perfect L shape or a perfect number 7. Those perpendicular rays are forming that 90-degree angle. So now if I look at example A, to the left of that clock, I'm circling in red pen, that's an example of an acute angle. So an acute angle is any angle smaller than 90 degrees. So if you notice any angle that's less than the corner of a piece of paper, it's smaller than the piece of paper, the corner of a piece of paper, it's acute. And remember the cheesy memory trick for it, it's a cute little angle, meaning it's a small angle, smaller than 90. So their example on the clock face of acute goes through the 12 and the 2. That's just one example of many of acute. If you go back to the right angle, the arms of the clock go through 12 and 3 for that corner of a piece of paper for 90 degrees. If I look at example C, obtuse means it's bigger than 90 degrees, but less than a straight line, but less than 180. So anything bigger than 90, but less than 180 is obtuse. And then finally, example D, any straight line, we could call it a straight angle, is 180 degrees. And we're going to be coming back to this vocab a lot, not just in this video, but in the next section's video as well. So it is important to keep in mind. And it does feel like, if you think back to your high school geometry course, it did feel like they were obsessed with the angles 90 degrees, 180 degrees, and 360 degrees. And we are going to see those angles a lot, especially 90 and 180 degrees in this course. Somewhere near the beginning of your MyMathLab homework for this section, you are going to see a protractor, which is a device used to measure angles. And they are going to put various angles on this protractor, and all they want you to do is to be able to use the protractor in identifying the measurement of certain angles. So let's see here the angle they gave to us, and I'll go through the steps of what you would go through in the homework when you encounter a similar problem. So if I wanted to know what is the measurement of angle ABC, I would use a little m for measurement. So little m. In the homework, it'll be in italics probably, that little m for measurement, the measurement. And I would draw the symbol for angle, which has the little arc through it. And I'm referring to the measurement of angle ABC. So if I follow A to B to C, I see that that last ray, that terminal side, goes through two numbers, a smaller number and a bigger number. When I say smaller, I mean a number less than 90, and bigger meaning a number bigger than 90. So you're going to have two choices. To correctly answer this question, you first have to ask yourself, did they give me an acute angle or an obtuse angle? Does this angle look like it's smaller than 90 degrees? Does it look like it's smaller than the corner of a piece of paper? Or does it look like it's opening up larger than 90 degrees? Does it look like it's opening up larger than the corner of a piece of paper? Well, if I look at angle B, it looks like it is acute. It's a small angle. It's smaller than 90. So if it's an acute angle, the smaller number that the terminal side goes through is going to be your final answer. So in this case, the smaller number it goes through is 50. So this is a 50-degree angle, and it's probably going to already have the degree symbol beside the answer box for you ready to go. So you would just simply type in 50 into the answer box and then click check answer. Now, what if, and excuse my horrible drawing skills here, but let's pretend that there was another side of this angle, and pretend I can draw straight, because I can't. But I'm going to have another side here, and I'm going to label a point up here, point D. And let's say now the homework wants to know, okay, what's the measurement of angle ABD? So first step, identify the angle they're talking about. So if I follow the letters in order, A to B to D, I see which angle they're talking about. Whoop. And then I ask myself, okay, if it's not a 90-degree angle and it's not a straight line for 180, then I ask myself, is this acute or obtuse? Well, ABD looks obtuse because it looks like it's opening up larger than the corner of a piece of paper, larger than 90 degrees, but less than a straight line, less than 180. So when it's an obtuse angle you're dealing with, you're going to only care about the larger number that the terminal ray goes through. So here, the larger number that it goes through is 120. So ABD would be 120 degrees. And again, they'll probably already have the degree symbol for you, so you would just type in 120 for the final answer. There is going to be some more vocabulary related to angles in this first section. Complementary angles are two angles whose measures have a sum of 90 degrees. So again, it feels like in geometry that they are obsessed with the numbers 90 and 180 when it comes to angles. So complementary, or even just complement, you want to think of the number 90. Supplementary angles are two angles whose measures have a sum of 180 degrees. So when you hear supplementary or even just supplement, you want to immediately think of the number 180. So complementary angles, when I put those two angles together, would form a 90-degree angle, the corner of a piece of paper. Supplementary angles, when I put those two angles together, would form 180 degrees, which was a straight line. So looking at example 1, it says if an angle measures 78 degrees, A, find its complement. So even though these definitions talk about the sum being 90 or the sum being 180, we are working backwards in this section when we are finding a missing angle. So when in doubt, we are going to subtract. And we said complement, when you hear the word complement or complementary, you want to immediately think of the number 90. So all I need to do is take 90 and subtract the given angle when it says complement. So 90 minus the 78 degrees that was given to me would give me 12 degrees. So the complement of a 78-degree angle would be a 12-degree angle. Why? Because if I put a 12-degree angle with a 78-degree angle together, I would get back that 90-degree right angle. So find its complement, just take the number 90 minus the given angle in the problem, done. Very similar, part B. Now find its supplement. We said when you see the word supplement, think 180. So now I take 180 minus the given angle, which is still 78. 180 minus 78 gives me 102 degrees. In other words, if I combine a 102-degree angle with a 78-degree angle, I get a straight line or 180-degree angle, straight angle. So whenever it says find its supplement, you just simply take 180 minus the given angle to get your final answer. I have thrown an extra example in the middle of this video because this concept is going to be used a lot, not just in this section, but in the next section. And it's so easy to overlook. So I just wanted to make sure that we get this concept down before we get into the bulk of the examples here in this video. So for this extra example, please excuse my horrible drawing abilities, or lack of, I should say. So pretend those are a straight line and a straight ray there. But it just simply says find the measurement of angle 2. So here's angle 2. Notice 2 does not have a degree symbol beside it, so that it is a label. Whereas the angle they gave to us is 45 degrees. This does have a degree symbol beside it, so 45 degrees is an actual angle measurement, whereas just the 2 is a label. All right, so the idea here is that angle 2 and the 45-degree angle are supplementary angles. They are adjacent to each other, so they're side-by-side angles. They're sitting right beside each other, or neighbor angles, if you will. They have this ray in the middle in common. And when you put these two angles together, I said they're supplementary because they form a straight line. They sit on top of a straight line. So when you put the two angles together, they do form a 180-degree angle. Remember, straight lines, straight angles are 180 degrees. So to figure out the measurement of angle 2, I'm going to start with 180 degrees since it is supplementary with the angle beside it and they're sitting on top of a straight line. So 180 for the straight line it sits on top of with the 45-degree angle. Whenever you're finding a missing angle in this section, you're working backwards, so you need to subtract. So 180, which represents the straight line, minus angle 2's adjacent angle, or side-by-side angle, which is the 45 degrees. So 180 for the straight line minus the adjacent angle is 45 degrees. So if I do 180 minus 45 degrees, I'm going to get 135 degrees as the answer to the measurement of angle 2. But just keep that idea in mind because the pictures are going to be a lot more complicated to come. There's going to be all sorts of angles to figure out in these bigger pictures. So a lot of times when people get stuck, it's because they forget that straight lines are 180. And if you're looking for a particular angle and you know the angle beside it, the adjacent angle, you just do 180, the straight line it sits upon, minus its adjacent angle to get that particular angle. So we did 180 minus the 45-degree adjacent angle, and that, boom, gave us the 135 degrees for the measurement of angle 2. Example 2, find the measure of the angle marked with a question mark. So not only can they use letters and numbers to label angles, apparently they can use question marks. So we're going to find this angle right here, which goes from here to here. The first thing that catches my eye is that behind both of the little angles put together is a box shape. As soon as you see a box shape, you should immediately think 90 degrees. So in other words, if I put together the 25-degree angle they gave to us in the picture, if I take that 25-degree angle and I put it together with the question mark angle we're trying to find, it forms a 90-degree angle. So these two angles are complementary angles. So 90 degrees for the box. Remember, when you're working backwards, you subtract to find a missing angle. So 90 minus the 25 degrees that's opening up part of the way of that right angle. 90 minus the 25 would give me 65 degrees for the final answer. So when you see a similar question in the homework, box means 90 minus the angle given to you that opens part of the way of the box, which was 25, for the final answer, which in this case was 65 degrees. Example 3 is going to showcase two important principles in geometry. So if we jump in, example 3 says, assume that the measure, remember little m means measure in this section, the measure of angle 1 equals 57 degrees. Find the measures of the other three angles. Okay, so let's go ahead and label that measurement of angle 1 in our picture so we can see this a little better. It said the measure of angle 1 was 57 degrees. Here's angle 1 over here. So it's 57 degrees. It wants us to then find angles 2, 3, and 4, their measurements. So the first important principle that it wants us to remember from geometry is vertical angles. It's about vertical angles. And when they talk about vertical angles, those are just simply angles across from each other. So whenever you have two lines or two rays or line segments even, that are crossing. Like here we have that X shape, we have two lines crossing. The four angles that are formed, we have two pairs of vertical angles. And vertical angles are just simply the angles across from each other or opposite of each other. Across from each other. And the important thing is that they are equal. So angles across from each other in any diagram, in any picture from here on out in this chapter are called vertical angles, and they are always the same measurement. They're equal in measurement. So keeping that in mind, which angle is across from our angle 1 of 57 degrees? Well, the angle right across from it is angle 3. So since vertical angles, opposite angles are the same, angle 3 must also be 57 degrees. So the measurement of angle 3 is also 57 degrees. Now, I could find either angle 2 or angle 4 next. There are lots of different ways to figure that out. But the next rule is the easiest one to forget. But I want you to focus on two angles that are side by side and sitting on top of a straight line. So I'm going to figure out angle 2's measurement next. And I'm noticing that if I put angles 1 and 2 together, they are side by side angles. They are adjacent angles here. So angles 1 and 2 are adjacent, meaning they are side by side angles with a side in the middle in common. Right here, this side in the middle is in common. So whenever you have adjacent angles, those are neighbor angles that share a side, sitting on top of a straight line, we need to remember straight lines are 180 degrees. That was on the very first slide of this whole video. So straight lines are 180. So to find the measurement of angle 2, 180, we're working backwards, so we're going to subtract, minus its adjacent angle, the angle beside it, which was 57 degrees. That was angle 1. So if I do 180 minus 57, I get 123 degrees. So the measurement of angle 2 must be 123 degrees. And I'll go ahead and relabel angle 1 again. Since I erased it, there we go. Notice, again, I just focused. If I'm trying to find an angle, I looked at the angle beside it. It's adjacent angle. I looked at angle 1 was beside angle 2. And I noticed they're supplementary angles sitting on top of a straight line. I immediately thought 180 minus that adjacent angle, which is 57, gives me 123 degrees. And since vertical angles are equal, the angle across from angle 2 is angle 4. Angle 4 must also be 123 degrees. So the measure of angle 4 was also 123 degrees. Now in the MyMathLab, even though we did not find these angles in numerical order, they would ask you to type them in numerical order. What do I mean by that? So the first answer box would ask you for the measurement of angle 2. So we were given the measurement of angle 1, so they'd say, okay, what's the measurement of angle 2? Then they'd ask you for the measure of angle 3, and then finally the measure of angle 4. All right, let's try a similar example to make sure we get that down. So example 4, again, find the measures of angles 1, 2, and 3. So I'm looking at the picture, I see an X-like shape. I immediately think, okay, let's look for vertical angles, angles across from each other, and also look for which angle they gave to you. So here they gave us this angle on the left side is 72 degrees. So which angle is across from it is angle 2 this time. So angle 2 must also be 72 degrees. And by the way, I should have mentioned this in the last example, but whichever angles, if you decide to put tick marks, the angles that are equal should have the same number of tick marks. So if I put one tick mark in angle 2 and one tick mark over here, that just simply means those angles are equal in measurement, or they're congruent. If I look back at example 3, you'll notice, I know I have a lot of circling going on here, but angles 1 and 3 had one tick mark, which means they are equal to each other. And also angles 2 and 4 had 2 tick marks, meaning those two angles are equal to each other because they have the same number of tick marks in them. They don't usually tell you which angles are equal in the MyMathLab, but I just thought I would mention that about the tick marks. If you do happen to see some tick marks in some of the homework questions, they're just saying to you, hey, these angles are equal. All right, we found measure of angle 2 is 72 degrees. Now, when you get stuck, chances are you need to figure out what angle is beside or adjacent to the angle you're trying to find, and is it sitting on top of a straight line. So I want to figure out angle 1 next, way up here, and a couple different ways I could do it. I am noticing that angle 1 is adjacent to a 72 angle here, 72 degree angle. Angle 1 is supplementary to the 72 degree angle. So, to figure out the measure of angle 1, since it's adjacent to the 72 degree angle, and since these two side-by-side angles are on top of a straight line, I immediately think of the number 180 for the straight line. So 180 minus its adjacent angle, which is 72 degrees. 180 minus the 72 degrees gives me 108 degrees. So the measurement of angle 1 is 108 degrees. And then what's across from angle 1 is angle 3. So vertical angles are the same, so angle 3 must also be 108 degrees. So the measure of angle 3 is also 108 degrees. And I'll put the same number of tick marks. You don't have to do this, but I will in 1 and 3, because 1 and 3 were both equal in measurement as well. So there we go. Angle 1 was 108 degrees, angle 2 is 72 degrees, and angle 3 is 108 degrees. Example 5 says, assume that the measure of angle 8 equals 29 degrees. Find the measure of each of the other 7 angles. And I see there's a label here that 2 out of the 3 lines are parallel lines. So parallel lines do not have any points in common. They never ever intersect. So what we have going on here is we have 2 parallel lines. In this case, it's the top and bottom that are parallel, that are intersected by a third line. And that third line that cuts through the parallel lines is called a transversal, which is a very fancy name for, again, a line that goes through 2 parallel lines. It's called a transversal. And something really neat happens when you have a transversal cutting through 2 parallel lines. So you have these 8 angles that are formed, and each of the 8 angles will have one of 2 answers for its measurements every single time. So you're guaranteed a pattern whenever you have a transversal cutting through 2 parallel lines. So all of the 8 angles that are formed by that transversal will have, again, one of 2 answers. So let me go ahead and just show you how I would do this particular question. If you do click on the question help button in the MyMathLab, it's going to explain it a little different. So if you prefer to do it the way that the MyMathLab homework describes it, that's okay too. They're going to talk about alternate interior angles being equal alternate exterior angles being equal and corresponding angles being equal. Feel free to click on the question help button for more information doing it that way. But I'll go ahead and just show you the way that I would tackle this question, because I don't memorize that vocab to get the right answer. So the first thing I would do is I would focus on which of the 8 angles they've given to you. So here they gave us this 29-degree angle, and I would start with that corner of the picture. We just said on the last slide that vertical angles, those are angles across from each other, are equal. So which angle is across from 29 degrees is angle 1. So the measurement of angle 1 must also be 29 degrees. Now I can find either angle 7 or 6 next. It doesn't really matter which. I'm going to go for angle 7 next. So many different ways to get the right answer. But I am noticing that angle 7 is side by side or adjacent to angle 8, which was 29 degrees. And these two adjacent angles are sitting on top of a straight line. So when I put the 29-degree angle 8 with angle 7, they are supplementary angles. So the measurement of angle 7 is 180 degrees for the straight line minus its adjacent angle of 29 degrees. So if I do 180 minus the 29, I get 151 degrees for angle 7. I'm going to erase a little bit, just so I have some room with my big old handwriting here to put this in the picture. I like putting everything in the picture because I think it's easier to see. I'm going to get rid of that label 7, so we know that's 151. I'm also going to get rid of that label 1. So once I figure these angles out, I'm going to get rid of their labels. And again, angles across from each other are equal. So if angle 7 is 151 degrees, the angle across from it, which happens to be angle 6, must also be 151 degrees. So the measurement of angle 6 is 151. All right, so again, we know that the other 4 angles that we have not touched yet, each of those 4 angles is going to either be 29 degrees or 151 degrees. Whenever you have a transversal cutting through parallel lines, each of the 8 angles will be one of 2 angle measurements every time. You're guaranteed that's going to happen. So here's the part where I do this differently than the Pearson's MyMathLab does. So what I would do is I would pick one of those 4 angles on the opposite side of the picture we haven't touched yet. So I'm just going to randomly pick angle 4. And I ask myself, okay, does angle 4 look like it's obtuse or acute? Does it look like it's smaller than 90 degrees? It's opening up less than the corner of a piece of paper? Or does it look like it's obtuse, opening up larger than the corner of a piece of paper? So I'm just kind of eyeballing it. And as I look at angle 4, it definitely looks obtuse to me, like it's opening up larger than the corner of a piece of paper. So since it's obtuse, and since it has to be one of the 2 angle measurements from the other side of the picture, it must be 151 degrees, because that's the only obtuse angle we've identified so far. So angle 4 must be 151 degrees. And the angle across from it is angle 3, so angle 3 must also be 151 degrees. And if you're not sure, angle 3 also looks obtuse. It looks larger than 90 degrees. So I would say it's a pretty good educated guess to say 151 for angle 3. And if you look at angles 2 and 5, they both look acute. They both look like they are opening up smaller than 90 degrees, smaller than the corner of a piece of paper. So angle 2 must be 29 degrees, just like angle 1 was. And the angle across from it, angle 5, must be equal. It also looks acute, so it must also be 29 degrees. So there we go. So again, all 8 angles must be one of 2 answers. Once you finish the corner of the picture where you were given the angle by using the vertical angles across from each other are equal and using the supplementary angles to get the other 2 answers, when you go to the other side of the picture, the obtuse angles will be the larger answers again, and then the acute angles will be the smaller answers from the other side of the picture every time. The only exception to this would be if you had all 90-degree angles, but that's not going to happen in the homework. But I just thought I'd mention it. You could technically have a situation where you have a transversal cutting through parallel lines and all 8 angles be exactly 90 degrees. But in the homework, it's going to be more like example 5 here, where they're all going to be obtuse or acute angles.